A very good morning to all of you. I cordially welcome you all for this applied thermodynamics course. So today's classroom discussion topic is problems on the heat balance sheet of a boiler. So the last class also we solved some problems on the heat balance sheet of a boiler. In continuation to the previous class, also we are continuing the same topic, that is the heat balance sheet of a boiler. So the motivation is same, that is it is very essential to know to draw the heat balance sheet of a boiler to assess the performance of a boiler. So the outcome of this lecture is you should be in a position to solve the problems on heat balance sheet of a boiler. So just you recollect the previous 3 to 4 classes theory, and already we solved some problems on the same concept of the heat balance sheet in the previous class. So in continuation to that particular one, so in the today's class also we are going to solve another problem on heat balance sheet of a boiler, so that you will be familiar with how to draw the heat balance sheet of a boiler, because I already told you that it is very important topic in the unit number 2, that is the boiler. So now this is the problem which has given. So he is asking us to calculate the heat carried by the exercise, and similarly the B bit is make complete heat balance sheet. So we have to draw the heat balance sheet. So now first you write down the given data, because for any problem first of all we have to write down the given data. So that is entire thing. So this is the given data. So that is here he has not given the specific heat of the superheated steam. So that's why we are assuming that it is equivalent to 2.1. I've already told you that whenever the specific heat of the superheated steam is not given in the problem, you assume that it is approximately equivalent to 2 kilojoules per kg Kelvin. So now based on the previous class theory, now let us do how to calculate heat carried away by the excess air. So we know that the flue gases produced per kg of the fuel burnt formula is so and so. So by substituting the nitrogen percentage, carbon, carbon monoxide and carbon dioxide, so we are able to estimate that the MEA1 value is equivalent to 21.83, and here the theoretical amount of air required for the complete combustion of the 1 kg of the fuel. So by substituting all the values in this particular formula, we are able to calculate it is equivalent to 11.55. So the excess air supplied, so that will be equivalent to MEA1 minus M theoretical. So that is equivalent to 10.28 kgs per kg of the fuel. So heat carried by the excess air, that is M excess air into CPG into TG minus TA. So that will be equivalent to 2988.4 kg kilojoules per kg of the fuel. So if you want to calculate the mass of the steam generated per kg of the fuel, so the formula, because we know that the H minus HF, H is nothing but he has given is the superheated steam. So the superheated steam formula will be equivalent to Hg plus Cp into T superheated minus T saturated. So go to the 55 degree centigrade temperature and note down what are these particular the values, that is at 1280 kilopascals from the steam tables. So these are the various value property values. So substitute here, we are able to calculate the mass of steam generated per kg of the fuel is equivalent to 8.75. Next, the important one is the heat balance sheet. So I've already told you that first of all we have to calculate what is the input, that is how much amount of the heat is supplied to the boiler by burning the 1 kg of the fuel. So MF into CV, so MF value we have taken as 1 kg into CV, that is equal to 35,000. So that is the input. Now all these output parameters we are having around 5 parameters we are having. So let us calculate one of the parameter of the output, that is the heat absorbed by the water per kg of the fuel during its heating and evaporation. The formula will be equal to MA into H minus HF1. So MA value is known to you. Similarly, H minus HF value is also known to you. So substitute here, you are able to get Q1. So in the similar fashion, now you calculate the Q2 also. The Q2 is nothing but heat carried by the dry flue gases, that is equal to mg into cpg into delta T. So mass of the dry flue gases is nothing but is a MP minus is a MV. What do you mean by MP is nothing but is the mass of the air plus mass of the combustible matters in the fuel. So all we know. So by substituting here, MP is equal to 22.73. And similarly, MV value. So to calculate MV value, the moisture found per kg of the fuel should be known to you. That is the 9 hydrogen. So 0.432 plus the fuel contains how much amount of the moisture? 0.018. So add this particular value so that it is equivalent to 0.45, so that the mass of the dry flue gases, so dry flue gases means is the MP minus the water vapor content, so 22.28. So substitute here, so CPG value you know, it is known to you, so delta T is also known to you, so by which we are able to calculate Q2. Now you calculate Q3. So Q3, that is the heat carried by the moisture, that is the formula. So you know all the values, that is at 0.08 bar, what are the values of Hg and T saturated. So by substituting this, we are able to calculate the Q3 is equal to 1366. And the last one, that is the heat lost by the radiation and convection losses and unaccounted losses, will be equal to Qin minus Q1 minus Q2 minus Q3. So by doing so, we are able to get Q4 is equal to 3710.2. Now, let us summarize in the form of the heat balance sheet. So that is Qin, that is equivalent to CV, so that is equivalent to 100%. So by summing up all these Q1, Q2 as well as the Q4, so we are able to get it is equivalent to 35,000. So that is equivalent to 100%. So far we have calculated Q1. So what is the percentage of contribution of the Q1 is 67%. Very good. So Q2, so that is how much amount of the heat is lost by the dry flue gases is a very high, 18.5%. And Q3 heat carried by with the steam in the dry flue gases, that is equal to 3.9%. And unaccounted losses will be equal to 10.6%. So the heat balance says that the input energy should be equal to the output, that is 100% will be equal to 100%. I hope the concept of the heat balance sheet is now familiar to all of you. I hope any problem which is given on the heat balance, now you are in a position to solve this particular problem. So with this, we are able to complete the unit number 2, that is the boilers and how to estimate the boiler performance. In the next classroom discussion topic, we will discuss about the unit number 3. Thank you one and all for attending this lecture on the heat balance sheet of a boiler. Thank you.